Hi, welcome to the channel Coders Arc, where we unravel the world of coding and architecture together. And in today's video, I will be talking about Model Context Protocol. I have done many videos in the past where I've talked about agents, large language models, and agent orchestration. In this video, I will explain how all of that is possible through a more standardized way across the industry using a protocol designed to solve the M cross N problem. Before Anthropic introduced Model Context Protocol in late 2024, anytime a language model or anytime a model application that needed to call an external tool wrote one-off non-standardized code and it created the M cross N problem. M models, N connections, just basically large number of one-off implementations. With Model Context Protocol, industry has standardized on one way to communicate with the external tools. Large language models get the context of MCP server tools that are exposed through the MCP protocol, which is built on top of JSON-RPC. In this video, I will explain what is JSON-RPC, how MCP standardizes on top of JSON-RPC, how the large language model agent, which is the MCP client, how the MCP servers, and how the API resources work together. I will also be talking about the three different decorators: the tool, the resource, the prompt, which are the most important decorators that every MCP developer should know. So without any further delay, let's get right into it. Before MCP existed, the legacy applications would invoke the internal APIs or database or any library code using the glue integration code, which was written by the human. Anytime the API endpoint schema changed, or the database structure changed, or the library code changed, the developers would handwrite that integration code and keep making the changes in different versions. The runtime path was frozen and the code used to make the decision. Now, with the widespread use of large language models and natural language querying, MCP was introduced by Anthropic to solve the problem of agent to server communication, basically agent to tool communication using a standardized way. Before MCP existed, whenever a large language model application needed to call an external tool, everybody would have their own separate implementation on how they would orchestrate that action. MCP took an aim to standardize this workflow. So essentially, whenever an agent is trying to orchestrate a complex workflow using the brains of the LLM, it uses the MCP server to give itself the information of all the tools that are available at its disposal, all of the resources that are there, all of the prompts that it can reuse. And then it knows the definition of these servers, it knows the definitions of these tools, and it knows what purpose the different parameters in these tools serve. So it knows when I'm executing a complex problem, these are the things I can invoke. So for example, we'll look at an example, but before we look at an example, let's try to truly understand what MCP is. MCP is built on top of JSON-RPC, and JSON-RPC is nothing but a dumb envelope. So the problem that JSON-RPC was used to solve is basically imagine a server that has a lot of functions. Now, if a client application wants to invoke all of those functions simultaneously, instead of making a separate API endpoint call to each server endpoint, why don't you give a one payload to the server which decrypts this payload and figures out a way to call these server methods in parallel? So imagine you have addition, subtraction, multiplication, and division endpoints that are sitting on the server side. Instead of calling them one by one sequentially over the network, I could just pass the JSON-RPC payload, which would have the name of the methods and the parameter names. And then the server will have a method that will take this payload, will parse this payload, and will know which methods to call. So this was an aim at standardization. Now MCP is an opinionated way on top of the JSON-RPC. So since the MCP server has a collection of the tools that are required by the LLM to solve a complex problem. The thing that you need is the name and the description, because description is what the large language model understands. A large language model understands the text, so it will know how to use this tool. Then it will have an input schema keyword, and the input schema keyword, you will have the name of the different objects, the different parameters, and their use. Why are they needed? For example, in this example, order ID, amount to refund, those are the descriptions of the different parameters. Now I'll explain the flow of how the LLM agent, MCP server, and the resource server, DB or an API work together. So the first step in the process is the agent makes a call to the MCP server using the tools /list call, and the MCP server responds back with the tools plus input schema that we saw in the last example. Basically, it shows all of the tools that are there, the descriptions of those tools, all of the parameters on how to invoke those tools, and the description of those parameters in natural language. The agent relays this information to the LLM, which is already thinking through solving the complex problem, and puts that information in the context of the LLM. So now that the LLM has additional context about the tool descriptions, and it hits a step in the workflow where it needs to solve through a problem that is solvable by one of the tools provided by MCP server. So it says, okay, agent, can you execute this tool on my behalf? The agent, which already has a connection, agent is the MCP client, has already a connection to the MCP server, makes a call using the tools /call, and the MCP server basically routes it to the right tool. So MCP server says, okay, go to the right API or the DB system to do the work. And when the work completes, let the agent know, or let the MCP client know that the work is done. And the MCP client or the agent relays this information back to the LLM. And the LLM continues to solve through a complex multi-hop reasoning problem. One quick thing I want to emphasize is MCP is a very opinionated take on top of JSON-RPC. So that's why if you carefully look at this payload, method keyword has tools /call. The method keyword already existed in JSON-RPC, but MCP always calls it tools /call. The params is a JSON payload that was optional, but it is going to be there with name and arguments. So basically MCP only defines which method names exist and what their parameters mean. The payload structure, the schema of the payload is the same as JSON-RPC. It's just the key values have changed. The key values is what is MCP's vocabulary. Template example, and in the prompt template, if you scroll down, you're going to see a decorator called mcp.prompt. Each MCP prompt function returns a string. It wraps a proper MCP prompt message automatically. The variables can be inserted into the prompt and before the prompt is sent over to the LLM. So if nothing, just know 3 things. You can practice your own examples. I'm not going to show, I think code you can easily generate these days. 3 most important keywords are tool, resource, and prompt. Any MCP server implementation is going to heavily use these 3 decorators. I wanted to also show you how this looks like when it's run in the real time. Now what I want to show is running the MCP inspector on the code that I created. Basically I created 3 different implementations for the MCP server. I had the tool implementation, I had the resource implementation, as well as I had the prompt implementation, because those are the 3 most important keywords. So the first thing is you connect to the server. And once you connect to the server, you will see tools, prompts, and resources. When I click on the tools, I'm connected to an endpoint that is serving these different tools. As you can see, MCP/tools call gave me all of the tools that are there. And if I want to invoke a tool, I just execute the tool and I can get the information from the MCP server. Same for resources. I have a full catalog resource when I did the MCP resource decorator call, it's a seeded database, and I got the information. Now I can take this information and seed it in the database. This is the information that is saved in the database. Obviously, as you saw, there were some tool implementation, basically read-write queries. So I have another query I can do. I can read the resource and I can get the information that is seeded in the database. This is coming through the exposing of MCP server. And finally, the prompts. For example, there is a prompts code review. These are some of the prompts that already exist in the system. And my aim is to fill the things with the right parameters. So for example, I say code 123, programming language, let's say C#, and focus, I say general. These are nothing but parameters. Don't get confused. You can have any parameters. But the point is that these get injected into the prompt. So the prompt already existed, but what you see is the language name, the code, as well as the structure that I've provided, the general structure. So as you can see, this is how MCP works. You can expose an API, a database, a prompt to be reused in a standard way multiple times by the LLM. Different backend APIs are exposed now as tools. The responsibility of the developers in this new era will be, how do we expose our current APIs, the legacy APIs? What parts of those are we going to expose as MCP servers? The trick is not to expose everything. The trick is only to bring in the tools that make most sense for your large language model workflows, for your agentic workflows. And then also there is going to be a lot of discipline in bringing the right set of security, the right set of performance for these tools that you will expose as MCP servers. That is a video on its own, and I will explain that in a future video. But hopefully through this video now you understand what an MCP server is, what the three decorators are, the tool, the resource, and the prompt, how MCP server is built on top of JSON-RPC, what is JSON-RPC, and what is MCP's standardization on top of JSON-RPC. And you understand the flow between the large language model, the agent, the MCP server, and the APIs. Hopefully all of that is clear to you now. So if you found the value in this content useful, please hit the subscribe button, and goodbye for now.